so I'll try and not be too loud. Yeah, thanks for coming along. Great to see so many of you. I was just saying to the organisers at the start, I think this is the best talk series in the North East on biology or ecology. It's so great to see so many people turning up on such a regular basis. So it's my privilege. Yeah, as Gordon says, I am going to be talking about climate change refugia for cold and wet dwelling butterflies. I will explain what refugia are in a second, but I'm going to talk about the bit that you're all here for, which is the butterflies first. And if you're anything like me, you're going to be looking forward to that moment in a few weeks when all of a sudden this sort of spectral, ethereal presence starts arriving in meadows. This is my local meadow at Seaton Sluice, and it's a colony of small tortoiseshell butterflies. Those three are arguing about sex. 'Twas ever thus. And you might be minded to send records to your local recording centre, obviously right here in Newcastle at Hancock. You might use something like iRecord as well, or other apps, or all of them if you want to. And all of that is so useful. And really, it behoves me to say, first of all, thank you for those of you that put your time in as naturalists and contribute towards citizen science data, which I'll go on to explain is so useful for the science that we do. We have a tougher job in the north, don't we? If you whichever way you look at it, from a European perspective, you can start to see that noticeably, actually, most of England, Wales, Ireland look a lot more like the rest of Western and Northwestern Europe, but already gaps start to appear in the north of Britain in terms of population density. And obviously Northumberland, least populous county of England, okay. When you sort of zoom in on Great Britain a bit more, you start to see, obviously what we're looking at there is like a reverse profile of the mountains, all right. And the other thing that's sort of quite noticeable when we now look at like the number of butterfly species in every square in Britain is that also starts to tail off towards the north as well, okay? So generally speaking, Gordon's quite right. Most butterflies seem to like it warmer than our summers in the north and northern part of the island, okay? The sum total of all that is that in the north, which is going to be the subject of my talk this evening, generally speaking, there are far fewer people. There's less of a recording scene, although like I already said, props to you guys and lots of others that do a lot of hard work up here, okay? Challenging conditions to survey, okay? We have a maritime summer, some of those are more maritime than others. And yeah, fewer species to find when you get there. All those people in the home counties dining out on, 40 plus species through the course of a summer without too much effort. It's a different world, right? But all this makes me think, as a northerner, well, I kind of want to do something about this. I don't know about you. And actually, a lot of the best evidence we have for how butterflies are responding to climate change does tend to feature those southern species moving towards the poles, moving northwards, okay? Absolute classic paper from Camille Parmesan, one of the foremost butterfly ecologists in the world, absolute classic, okay? One of the first to consistently describe the fact that butterflies were very much indicative of a wider trend towards species arriving further north. And of course, we all get quite excited when this happens, when new records of southern species arrive. Generally speaking, this graph from Rachel Hickling, you don't need to look at every single group to realise that most of those bars are above zero. In fact, most of them are kind of around 50 kilometres. That's a distributional shift over sort of 20, 30 years using your citizen science data. And almost everything is doing the same thing. You've got reptiles and amphibians doing something a bit different, which could be a whole other HSN talk I won't go into that just tonight. This is almost a better way of putting it. I love this video. I play this almost every video where I have citizen science data. It's almost like bombs of citizen science data are going off via different groups. The blues are invertebrates, the reds are vertebrates, fungi, plants on there. And you can see those records accumulating by Julian Day on that graph there. But if I sort of take us, I think I can do that, we have the technology, once we get to December, that pattern is there again, okay? And as citizen scientists, we're pretty thinly spread across northern Britain, okay? And when we citizen scientists go out into northern Britain, the conditions can be challenging, as I said, okay? Here are some of my disillusioned research assistants, I promise. I looked after their welfare throughout, and no field assistants were harmed in making of this talk. What if I told you that that picture at the top was the hottest day in Scotland in the summer of 2016? It's true. It's true, that's Glen Lyon. And yeah, even when it is nice, that is the top of Craig Meggy, 1,000 metres up. That's a bit of a day out to get up there to do surveys. So with the weather being able to turn at any sort of minute, this is one of the reasons why we have far fewer observations. So broadly speaking, there are a handful of other reasons why this sort of science is more difficult, okay? So what in the jargon is called a type 2 error, where you go along to a site and you falsely don't observe a plant or animal that is actually there in reality. This is a very real problem. It could just be too cold. You could have slightly missed the weather window. Anyone that's been out and looked at mountain ringlet butterflies will know all about that. They can come back as well. So these cold and wet dwelling species, they might look like they're going disappearing from a site, but they can come back, and that's a happy thing to happen, of course. But you've got to be a bit more sure, right, when you're looking at recolonisations to make sure that you can rule those out, okay? And yeah, when things do survive or not, there can be quite a bit of mess and other biological mechanisms going on when species retract. When species disappear from a site. It's far more straightforward when a species just arrives and colonises a new site. Okay. So there are other reasons as well, but there are lots of things about this that make it quite a wicked problem and quite a lot of fun to go and do field work for. Okay. That said, I would describe it as squeezing the most out of the citizen science data that we do have in northern Britain or the north of England, and trying to do good science on it and trying to work out what's happening with some of the incumbent native species that we have, and not just get excited about the ones that arrive. Okay, so those are two examples. Again, I won't go into the detail of what we found, but needless to say, climate change was having a very real effect on all of them, all the species that we studied. Okay, so in sum, what I've just sort of introduced and discussed to set up the problem, okay, there's a number of geographical, biological, methodological, anthropological challenges. No wonder people don't often attempt it, but some do. And actually I would say that if you're interested in an introduction to what's going on with the northern butterfly species, this paper is a really nice kind of feel for what could be going on with invertebrate populations in the northern half of the country more generally, okay? So what these graphs show is that with the top panel, as you go towards the north, okay, far less likely for these butterfly populations to go extinct. There's three graphs, three butterflies there, okay? But for the mountain ringlet on the right-hand side, it's actually retracted to higher elevations. So those higher elevation species are more than 50% less likely to have gone extinct more recently. And 3 of those 4 species, that pattern is consistent with what we'd expect with the climate getting warmer in the south of their range. Okay? And this is still being used today. Like just last year, paper in Science, it was the go-to reference for cold and wet dwelling species worldwide, okay? And our main aim was to try and see if anything had changed for those butterflies since then, okay? But before I sort of lead into what we discussed in terms of the fieldwork, what I'm just going to do is introduce why what we're interested in is finding these climate change refugia, okay? So refugia is a sort of jargonistic term, and I apologise for sort of introducing it so late in the day on a Monday, okay? I've actually found that rather than just try and define this in words, it's better to just show you the sorts of things that I mean, okay? Some of these examples from the south, some of them from the north of Scotland, okay? You'll probably be familiar with most of them, okay? It can be micro-topographical valleys, like Kynance Cove, if you've been down there, and the Lizard in Cornwall, okay? Phenomenally different biota from what you get on the tops, Goonhilly Downs, okay? Got its own microclimate, and of course that's part of the reason why they're so unique, okay? The Langdales themselves also contain very interesting kind of flora, topographical sort of heterogeneity. In that particular photo, you can see the effects of a temperature inversion on the fire smoke, the coal fire smoke. It's holding it at the bottom of the valley, okay, where it's a lot cooler. And that allows cold and wet species to survive, where otherwise they might be suffering from warmer temperatures, okay. Can exclude other competitors. There's lots of ways in which it can work in their favour. Got places like Winterbourne Downs, where actually RSPB have gone out of their way to create this difference in slopes, these chalk slopes, facing lots of different aspects, including north, okay? You can see it in that picture with the digger, shaded side, okay? That gives more opportunities for cold and wet dwelling species to persist close to where they live, okay? So the climate warms and they can choose a cooler microclimate. And then you've got the Durrock Forest in the Northwest Highlands of Scotland, definitely a cooler refugia in a more general sense, but here you can just see this sort of steeply etched valley that's really holding on to a much different biota from what's around it, okay? So generally speaking, that word refugia, I will use it a bit through the talk, okay? It's just large enough to support a small population of some species, and generally that's atypical or different from the wider environment, okay? So, why are we interested in these refugia, and why would we want to sort of follow up on Aldina's work? Well, Aldina did a very good job of surveying these butterflies and linking them to elevational and latitudinal range shifts, okay? But she didn't do a huge amount to exactly work out what the climatic requirements of those species are, of course. And, okay, some species do have an awareness of what latitude they're at and potentially elevation, but largely it's going to be the climate that they're responding to, and that's why they're retracting in the way they are to these refugia. So we kind of want to tie it a bit more closely to climate data, which I'll do later in this talk. Okay. Lots of other good reasons. We just want to know more about the species, natural history. Okay, for these species we know a lot less about. We want to understand where species move to, those dynamics. Okay, and we want to try and conserve them, because by 2100 it's going to be a lot hotter, a lot drier. And yeah, what potential do these refugia that I just showed you have to facilitate those long-term persistences? Okay. And these are the stars of the show. Probably should have introduced them a little earlier. Okay. I should have quizzed you on them, shouldn't I? So that's northern brown argus at the top, okay, Refugia artaxerxes, accidentally capitalised, apologies, mea culpa. Scotch argus in the middle, quite a wider countryside species in Scotland, very niche in England, okay, large heath butterfly, we've had great talks about that this term already, okay, and the mountain ringlet that likes it up on the tops of hills, okay, and obviously there's 2 Refugia species, there are dozens of those Refugias in the Alps as well, they're quite a montane temperament. Just to kind of take you through like a quick kind of state of the nation for each of them, okay. Northern brown argus, declining, that is actually a log scale, obviously more biologically relevant, but the line's going down. You've seen those graphs or variants of them many times, okay. Slightly different colour morphology as you move into Scotland. Some of you lepidopterists will probably be well aware of that. But also, it hybridizes with obviously congeneric southern brown argus too, okay, Refugia gestis. Generally speaking, the dividing line is actually not that far from here, really, okay. So, broadly speaking, everything north of that is the species that I'm going to discuss, although obviously what we need is very smart people like Amy that can sequence this stuff to truly tell us which is which, because visually they're very similar. Single brooded, out once a year, very much kind of in the peak in terms of temperature. Scotch argus, well, pretty neutral trend actually, and like I say, a wider countryside species. Not that specific with its host plant in Scotland. Millennia is found in lots of places. Like I say, it seems to be doing quite well. Bit of a latecomer in the summer. If you want to see a butterfly in August, this one will probably be on your list, especially if it's late in the day. Late in the season. The large heath, a bog specialist. Host plants are bog specialists, although hare's tail cottongrass can be found outside of like strictly wet areas. Happily, a very increasing distribution, and thanks again to those of you that are involved in conservation efforts in bogs, upland or lowland, for this species. Okay, lots of hard work by groups like the Bog Squad, RSPB in the lakes, and also sort of lowland Yorkshire as well. Again, it's single brooded. There's actually differences in the number and the vibrancy of the eye spots. The further south you come, the more vibrant they are. Okay, there's 3 subspecies for that one. And then the mercurial mountain ringlet. No, I haven't forgotten the graph there. We don't have a graph. Such is the little amount that we know about this species. So few people are able to walk a transect for this species on a regular basis that we do not have reliable data for its population trends, okay? Largely occurs in the lakes and the western highlands with outposts and cairngorms and the kind of A9 corridor. Single brooded, but I will already give you a health warning. For some of those populations, they can easily be over by the 2nd week of June, whereas in Scotland, they can go into August. Again, it's our lack of quality data that's kind of doing that, okay? Host plants, not quite bottomed out. It could be that they use different plants, different stages, different larval stages, okay? Probably mat grass, which is quite widespread. Butterflies not found there, we know not why. So yeah, again, a very good species to do science on. And because Aldina's team and in a paper did some hard work on what we think is happening to these species, we do have some predictions, some hypotheses about what might happen with them, okay? We think that northern brown argus, Scotch argus, and mountain ringlet might be responding to warmer temperatures directly. But with the mountain ringlet, being a montane species, there could be something going on with the snowlight. I'll come back to that. With large heath, being a bog specialist, we think it might be something more to do with moisture, okay, or precipitation or some sort of water balance. Alright, but that's what we think is going on with them, and that's what we're going to investigate through the talk. And to do this, we make use of lots of data that we've already got, luckily. Okay, so yes, myself and a fantastic team of field assistants resurveyed all these places where you as citizen scientists visited, and that those comprise the 2 atlases of butterflies in Britain and Ireland, okay, and the butterflies of the new Millennium dataset, as it's now known. And then, of course, we also went back to the squares where Aldina and her team visited as well. And we went to lots and lots of 1 by 1 kilometre squares, okay, so some pretty decent, fine-ish scale detail on where they are, okay. Not 10 kilometre squares, not hectares, okay. And there's a rough separation between them, so we've got a bit of a chronology, a bit of a history for those sites too, okay. And yeah, I mean, this is what you came for. I'm not going to fool myself. You're not interested in the statistical model and significance, okay, although I will give you some of that towards the end. You're welcome to go to sleep in that part. But there's a whole project Flickr, if you're interested in beautiful pictures of butterflies and less beautiful pictures of people like me. All the landscapes we went to and what we found, it's all up there, okay. What did we do when we got there? Well, I mentioned 1 by 1 kilometre square. Don't be thinking this is Scotland, by the way, this is the Dolomites, but I couldn't find a better picture to illustrate. So we went to 100 of these per species, okay? 100, so that's 400 over 2 summers, okay? And we re-walked what are called belt transects, butterfly monitoring scheme, okay? If any of you have ever done that before or familiar with those data, it'll be very familiar to you, okay? Basically, you just sort of got to imagine like a belt around you, and you observe the butterflies as they come into the belt or the box, okay? And you note them down if they come into the box, okay? So a standardised methodology that we kind of rolled out. We modified it slightly though, because obviously we fitted it within the 1 by 1k box, but we also had a bit of contingency time if we didn't find the butterfly. So we spent 1 hour walking that transect, and then we spent another 30 minutes just looking in the places that we thought we might find the butterflies in case we didn't on those routes that we took, okay? And we made sure our transects covered any records that we already had for the species at 100 metre level or finer kind of resolution, all right? So we're maximising our chances of making sure that we found them. Again, a bit of jargon there. This is making sure that what we're seeing as a positive is actually positive, okay? So we made sure that we gave everyone a GPS unit so that they weren't here and that they were in fact in the square, okay? We did make nets compulsory to make sure that people weren't just trying to identify things a long way off and getting it wrong, okay? And we supervised people introduction, okay? So those of us that surveyed butterflies before made sure that we trained people up and went out as pairs before we could do it individually, okay? And then, yeah, making sure that we didn't rule a square out as being absent when actually the butterfly was hiding from us, okay? So like I say, we visited any fine-scale records from the Citizen Science Database or from Aldina's survey. Like I say, we added extra time if we didn't find the butterfly. And then, for any sites where we thought the butterflies were genuinely absent, any one of those species, we actually went back to 10% of them. So that's 10 sites per species to just double check what our failure rate was. And it was pretty low. It was around 10%. Okay, so we were getting it wrong. Of the ones that we thought were absent, we were getting it wrong we were getting it right 90% of the time. That's a better way of thinking about it. Okay. So we were pretty confident that the method was giving us the result we wanted, which is just the status of the site for each species. Okay. Now, I've already talked about we were interested in what the effect of climate change is, but of course the habitat can change too, especially over decades. There have been a number of changes to agricultural policy that could mean that vegetation height, the mix of species could change. Okay, so we did host plant surveys, and we also measured vegetation height to think about things like headage payments, pressure from deer, etc. Okay, I'll come back to those later, but we did do them whilst we were there. And yeah, this resulted in quite like a scientific, it looks like a relatively complicated protocol, but this is just like the formal expression of what we did. Lots of yes, no, this is what we did. And then ultimately, all that is designed to make sure that we're 100% sure that we haven't falsely ruled out an absence and that we're as confident in the presence of each butterfly at each site as we can be. Okay. Massive team of people to thank for this, like a real inspirational group of people that I worked for in my time at York and continue to work with now. Jane Hill, Chris Thomas, and Aldina Franco has been heavily involved as well, and I had a great team of people that helped me sort of survey these butterflies too, and sort of very indebted to them for putting the miles in. So thank you very much for coming, and do send me an email if any of this sort of caught your attention.